Welcome, I'm presenting our paper Mixed Memory RNNs for Learning Long-Term Dependencies in Irregular Sample Time Series. This is a NeurIPS 2022 workshop paper at the workshop Memory in Artificial and Real Intelligence. The paper we talk about ODE RNNs, which are a nice tool for processing irregular sample time series, and this is where the input events are not uniformly distributed in time. One nice properties about ODE RNNs is that they have an implicit notion of time. In particular, we have here an ODE RNN in the form of ODE GRU, where we have a normal GRU that processes the hidden state and the input, and then followed by an ODE that is learned. The nice property is that actually this ODE parameterizes the time derivative instead of defining a single time step update function, and therefore this has very nice properties on certain datasets where we have like superior generalization performance. Our result in this work, we show that ODE RNNs tend to suffer from the vanishing exploding gradient, and this problem has been studied for discrete time RNNs already, but we also show this for ODE RNNs, and we show that this is regardless of the choice of ODE solver. And we also show that this also applies to the GRU ODE, for instance, like the ODE GRU that we've seen before, because we're processing the hidden states with an ODE which introduces this vanishing dynamics or exploding dynamics. And we show also how to resolve this, in particular by using mixed memory RNNs, and the idea is to separate the time continuous from the memory state. So essentially, instead of having a single hidden state, we have now two: a CT, which is the memory, which realizes a near constant error transport, and a second HT, which is this time continuous state, which we allow to vanish. The long-term dependencies can still be learned through the memory pathway. Particularly here we have a table showing the difference how the ODE RNN differs from MMRNN. In particular, we see that between two observations, the ODE RNN just applies the ODE solver, versus the MMRNN separates the two states. We also computed the gradient norms for different sequence length of an ODE RNN and an MMRNN, and show that that the MMRNN helps to keep the gradient norms reasonable. We also proposed two new datasets for irregular sample time series which require memorization. The first one is a bitstream classification, which can be represented as both an irregular sample time series and an irregular sample time series if we use for the 0-1 encoding an event-based or run length encoding. And the same can be done for the MNIST, where we binarize the input and represent the MNIST as a time series, and then merge consecutive zeros and ones to have a run length encoding, so an irregular sample time series. We then performed an experimental analysis with different methods and showed MMRNN achieves the best performance on these datasets. Thank you.